So in this video, we're going to introduce the idea of systems of linear equations. Now, what a system of linear equations is a collection of equations that all have some sort of linear form. And what we mean by linear form means that we just have n variables, right? We see here x1 to xn, and then we have our first equation here, a11 x1 plus a12 x2 plus blah 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 a1n xn, and that's equal to some value. So no products of the variables and no higher powers. And then we have the second equation, a21 x1 a22 x2 blah 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 and so on. And then in this case we have m of these equations. Now this is the most abstract and general way to express this. Maybe it's easier to talk about this with some sort of concrete example. So maybe something like 3x1 plus 2x2 plus x3 is 7. 2x1 plus x2 minus 4x3 is 2, and maybe x1 minus 4x2 plus 3x3 is negative 1, say. And so, right, what we have are, in this case, this is a 3 by 3 system of linear equation, meaning that we have 3 different variables, x1, x2, and x3, and we have 3 equations that need to be satisfied, this one, and this one. And so we are going to begin our conversation about systems of linear equations by first talking about what it means to be a solution to a system of linear equations. So in this case, what it means is that we give a value to x1, we give a value to x2, and we give a value to x3 so that this equality is true, this equality is true, and this equality is true. What we're looking for are a value for each one of the variables so that all of the equations are actually true statements. So before we even get into how we go about even trying to find a solution to a system like this, I'm going to talk a bit about what type of scenarios are possible. And in order to do that, let's simplify this even further and break it down to a much nicer, simpler system. So let's say we have 1x plus 2y is 4, and 3x plus 3y is 9. Right? This is a simpler system than the one we wrote before. This is a 2 by 2 system, 2 variables, 2 equations. And so what we're looking for is 2 points that or a value for x and a value for y that satisfy both of these equations, meaning that x plus 2y is 4 and 3x plus 3y is also 9. Now the thing to observe is that in this case, each of these equations describes a line, right? And so all of the points that make this first equation true, what are some examples? So 4, 0, 0, 2, 2, 1, etc. All of those points, when you put them together, form a line in the plane. And the same thing here. If I look at all of the points that make this true, 3, 0, 0, 3, 1.5, 1.5, 2, 1, 1, 2, 4, negative 1. Those all form a line in this space as well. So what point lies on both lines? Well, we could go ahead and ask ourselves that directly, right? We could plot one line. Let's just, there we go. We can plot one of the lines. We can plot another line. And there we have it. We have a solution. X is 2 and y is 1, right? The solutions to the first equation form a line, solutions to the second form a line, and when we put them together, there's only one point that lies on both. So, and to check this, we can see, all right, 1 times 2 plus 2 times 1 is 2 plus 2, which is in fact 4. And then 3 times 2 plus 3 times 1, that is 6 plus 3, which is in fact 9. So yes, that is a solution. So one of the things that could happen is there could be a unique solution. If we take a look at what we've plotted here, there are no other points, right, that lie on both the first line and the second line. So when we solve the system, there's only one point that satisfies both lines, and we found it. Oops. There we go. All right. The other thing that could happen is, let's come up with a new system. 2x minus y is equal to 8. It would be 6x minus 3y is equal to 24. So if I go ahead and approach this the same way as I just did, then let's go ahead and replot these lines. 2x minus y is 8. 6x minus 3y is 24. Now what we see is that we've actually written the same line in two different ways, right? We have 2x minus y is 8, and then 6x minus 3y equals 24, which is just scaling everything in the first equation by 3. And if we factor out a 3 from both sides and canceled it, we would be left with the exact same equation. And so, since these two lines lie on top of each other exactly, right, every single point on this line is in fact a solution. So here is a solution for 0, but also 6, 4 is a solution, and 0 minus 8 is a solution, and every single point on this thing is a solution. So one of our other scenarios is that there are in fact infinitely many solutions. Now, the third scenario that could happen is, let's go ahead and come up with a straightforward example of that. Let's say x plus y equals 4 and x plus y equals 5. So here's a system of equations, and without even plotting it, we can already see that there's something wrong with this system, right? Because if x plus y, sorry, no one can see that. If x plus y is 4, then there's no way that x plus y is also 5, right? It's either 4 or it isn't. So there aren't going to be any values on the plane at all where you could have both of these equalities hold at the same time. And to sort of see what happens if we try to do that, x plus y equals 4, and then we talk about x plus y equals 5, right? We are talking about parallel lines that don't ever intersect, right? There are no points on one line that are also on the other line. There's simply not such a scenario. So in that case, we could say that there's no solutions. Right. So what we have here are the three possible scenarios. We can either find a unique solution to our system, or there are infinitely many solutions to our systems, or there aren't any solutions to our system. Now, it's reasonable maybe to ask, like, oh, is there a scenario where maybe you have exactly two solutions? But think about what that would mean. If you had exactly two solutions, that means you had two lines that crossed, two straight lines that crossed at two different points. And that's just not a scenario that can actually occur, right, in our space here. If 2 points lie on a line, that uniquely determines the line. The other line that intersects those 2 points would have to be the exact same line. And so there isn't an in-between stage between unique and one solution and infinitely many. Your choices are 0, 1, and infinitely many. Alright. Thank you very much for watching. As usual, if you have any questions, please let me know. In the next video, I will be talking about how to actually find these solutions, particularly when there are more variables involved. It's pretty straightforward with just two, we can graph them, but when there's more, things get more involved.